The shipping industry is faced with the challenge of developing energy-efficient ship designs compromising innovative technology. In 2020, sulfur limits for fuel will globally apply. Diesel quality fuels demand a premium estimated to be 50% of heavy fuel oil price. Also, CO2 emission charges could become effective. Scientists believe that by 2020 the CO2 emissions will increase by 30%. Often the solutions are already available but are not immediately recognized. In 1925, the Bukau implemented a piece of technology which was extremely innovative for that time. This is the foundation for the following concept. It was the first rotor ship in the world. The wind hybrid coaster consists of the creative ideas and expertise of 15 MariTIM partners. This resulted in an innovative concept that meets and exceeds all current demands. The wind hybrid coaster can introduce 10 to 30% fuel savings, resulting in less CO2, SOx, NOx and other emissions. These 10 to 30% savings are based on the annual average. The ECO FLETTNER-rotors act additively to the propeller and can take over 100% of ship propulsion under optimal wind conditions. The rotor drive is therefore a full functional and independent propulsion system. The ship's main engine consists of 5 300 kW generators powering an electric motor with the respective required energy power up to 1200 kW. This power allows a service speed of about 12 knots. The ship has a cargo capacity of about 4,000 deadweight tons. Under engine operation, the ship carries 3.3 tons per kilowatt. This ratio increased to 26.7 tons in pure sailing operation. The wind hybrid coaster implements the rotor technology using 2 ECO FLETTNER-rotors on the main deck. This assistive wind propulsion system consists of 2 18-meter high and 3-meter wide ECO FLETTNER-rotors with a sail area of 108 square meters. The end plates have a diameter of 6 meters. The spinning ECO FLETTNER-rotors creates a lift that pushes the vessel ahead. This force is called the Magnus force. By rotating of the ECO FLETTNER-rotors, the wind flow at the front of the cylinder is accelerated. This results into a suction effect. At the back of the cylinders, high pressure is built up. The combined pressures creates a driving sail force and pushes the ship forward. The effectiveness of the rotors is dependent on the ship's course, wind speed and direction. This diagram shows the generation of propulsion power depending on wind direction and speed. This quick example demonstrates the efficiency of the wind hybrid coaster versus a current conventional freighter. The trading route from Rotterdam to Istanbul is being used for this example. As seen on the graph, the wind hybrid coaster speed and fuel savings are impressively high in comparison with the current conventional freighter. On this voyage from Rotterdam to Istanbul, the wind hybrid coaster could reduce fuel consumption and emissions. Alternatively, the ship could arrive 28 hours earlier. The wind hybrid coaster has the following advantages. And in the future, we would like to introduce a zero-emission ship built on rotor technology.